Mic on? Can you hear me? Mic? Yes? Good? Yeah. Cool. So my name is Louis. I'm a technical lead at REA.
Hey, I'm Rahul. I'm a technical lead at REA as well.
And in our day jobs at REA, we mostly work on sort of domain-driven microservice architectures using Ruby. But we're here today to talk to you about, sorry, this is us on the internet. We're here today to talk to you about Elm. And that's just something that we've taken a big interest in recently. And so I'll try and answer your first question, which is what is Elm? So if you go to the Elm website, what you'll be told is that Elm is a delightful language for reliable web apps, generate JavaScript with great performance and no runtime exceptions. So in order to sort of illustrate to you really quickly what Elm is, I just want to run through those statements. So Elm is delightful. You'll have to take my word for that for now, but I assure you that it is truly delightful. Language. So Elm is a programming language. It's not a library or framework that you add to your apps. It's a whole new programming language. For reliable, well, we want our apps to be reliable, so I'll kind of take this one as a given and move right along. Web apps. So Elm is a programming language to write web applications specifically, and even more specifically, web applications that run in the browser. So it's a client-side programming language. Generate JavaScript. Elm compiles into JavaScript, so you write Elm code, turn it into JavaScript, and then send that into your web pages with great performance. Similar to reliability, of course, we want our apps to have great performance. But what I will say is that Elm uses a virtual DOM implementation, which if you're familiar with React, it's very similar technology, and in benchmarks, it does very well compared to React. So you will get great performance. And finally, this I think is the most interesting one that kind of got buried at the bottom here, no runtime exceptions. So Elm promises that you will write code that will never throw a runtime exception in the browser, which is really interesting. Most of us are very familiar with runtime exceptions in Ruby, and we're, of course, also familiar with runtime exceptions in JavaScript. Just leaving that there for fans of the surrealist movement. So if that answers what is Elm, just enough to sort of give you a framework with which to understand the rest of the talk. The next question is, why should I care? And I want to spend a little bit of time, first of all, just sort of saying why we think that Elm is really interesting, why it's worth your time. First of all, in a general sense, but also specifically for the Ruby community and for Rails programmers as well. So I want to loop right back to that thing about no runtime errors, because that seemed really interesting. So let's talk about that a little bit. In order to talk about that, I'm going to dive into one particular language feature in Elm. It's not the only thing that prevents runtime errors in Elm, but it's one of the things. So I will show you a little bit of syntax. Don't panic straight away, because we're going to talk more about the language and its features and its syntax in a little bit. But I'll just show you one quick example to give you an idea how Elm achieves no runtime errors. So this is some Elm code. I'm defining a type of a user. So you can think of this kind of like a class in Ruby. All I'm saying is it has a name, it's a string, state that's a string, and a phone number, which is also a string. So straightforward. Then I'm defining a list of area codes. So it's a dict, so dictionary, which you can think of kind of like a hash in Ruby. The syntax for defining it is weird, but don't worry about that. Think of it, it's just like a hash. So I'm mapping states into area codes. And then finally, I have, and if you've spotted the bug, don't shout it out, because I know there's a bug. Finally, we have a function, display phone user. So this is the way you define functions in Elm. There's no def, there's no parentheses, there's no anything. You just have the name of the function, list of parameters. So display phone takes a user. Everything after the equal sign is the body of the function. So we're doing dictionary.get, which is just pulling a value out of that dictionary. So using the user state to get the area code, concatenate that with the phone number using the ++ operator, so you get this phone number for display, which includes the area code. So I said there's a bug in this code, and some of you will already have seen what the bug is, and the bug is, of course, that I have forgotten Tasmania. And I want to stress that this is purely a hypothetical example, and I'm sure no one has ever forgotten Tasmania in production code. So the thing about this is, if you had code like this in Ruby, what would happen is you'd try and get the user's area code out of that hash using the state. You'd get nil back, and then you'd try and call ++ on nil, and you'd get no method error, and that would blow up at runtime for your users and throw a stack trace. The thing about this code in Elm, the interesting thing about this code in Elm is that it just will not compile. I can't take this code and turn it into JavaScript to run in the browser. And the reason is this. This is the this is the error message I get when I try and compile this code in Elm. And I just want to take a moment to highlight how amazingly awesome Elm's error messages are. So all of the error messages in the language are this good or better. They have colors, they have underlines, they have hints. Some of them are really, really specific hints. There's a whole repo on GitHub where you can go and say, this error message confused me, and then they will just try and fix that error message. So what's happening here is I call dict.get on my list of area codes, and it's saying that plus plus here is expecting an appendable, and appendable is either a string or some text or a list. But what I actually got is a maybe string. And so what does that mean? For those of you who are familiar with sort of typed functional programming language, you'll be familiar with the concept of a maybe, and it was, I think, alluded to in Tim's dry RB talk yesterday morning. So what is a maybe? Thank you. Glad someone got that. So what happens is I call this dict.get function here. I'm pulling a value out, but I don't know whether I've got a string or whether I've failed and I got nil, right? So this method this function can succeed or it can fail. In a language like Ruby, we just assume that it succeeded because you get back a string and you can start operating on that string straight away as though your method succeeded. So you're not forced to handle the nil case. In Elm, what I get is a maybe, which means that I have to actually unbox that value before I can use the string that's inside it. So it's like a box that might have a string inside it or it might have nothing, and I need to handle that. I explicitly have to handle that. So what that looks like here, so I use a case statement. Don't worry too much about the details. Again, we'll talk a bit more about the syntax shortly. But maybe can have two values. Maybe string can either be just string, or it can be nothing, the special value nothing here. So if those are the two branches. Top one, if it's just a string, I match the string out, bind it to that area code name, and then use that in concatenation. And at that point, it's safe because I know I had something. In the other case, I had nothing, so I can add the special area code unknown message. Of course, this is still a bug. It's still not great for users in Tasmania because they don't get the area code. But it's a lot better than a stack trace or the runtime crashing. And yes, I know that in JavaScript, you can safely concatenate nil to things, and it will just give you the string nil followed by the other string. But you can take this as a placeholder for any kind of like function call or object access in JavaScript. So that's part of the answer of why should I care. And more generally, like it's great that you can write applications for the browser that just won't crash in the browser. That's great. There's a couple of things specifically for the Ruby community that I think are cool about Elm. And one of those things is programmer happiness, this idea that languages should be fun to use. And I feel like Elm is created with a very similar design aesthetic, although I couldn't find an actual quote to that effect. But you can see it throughout all the aspects of the language, the tools, those error messages. Elm has a lot of concepts like monads and things like that, but it doesn't use those words in describing them because it's trying to be really accessible to beginners. And you'll see more examples later on of why that's the case. Another thing that I like about Elm, and this is particularly interesting to people who come from a Rails background, is I kind of have this model in my head that I want everything to just fit together and not have to make a bunch of choices about how to wire everything together. And so Elm definitely does that. In this case, you can see the only one that's different at the end is Elm test, and there are currently talks about bringing that into core so that even that one would be sort of part of the batteries included. The other thing is for Ruby and Rails programmers, Elm has kind of a low barrier to entry, so I don't have to, I need to drop Elixir in here somehow. So what I'm going to say is if you want to use something like Elixir, basically that's replacing something that you would have written in Ruby, so you're writing less Ruby. But if you're using Elm, you don't have to deploy a new application or a new part of your application. You can put it in your existing app because it's replacing some JavaScript. It's not replacing Ruby, it's replacing JavaScript. So you write less JavaScript, but the same amount of Ruby. So it has just a really low barrier to entry. I got one more. So with all that out of the way, I hope I've given you some reasons why we think Elm is cool and why it's interesting for us as a community. And I'm going to hand over to Rahul to sort of give you a little bit of a crash course in Elm syntax. But of course, Elm does not crash.
So Elm basically gets most of the features from academic languages, but it tries to be like very, very manageable, and programmer happiness and friendliness is like the main key item that they actually focus on. So they try to do things very, very easily, right? Or make things easy to use. So this is going to be a very short course in Elm Syntax, so like just after lunch, so don't hate me for this. As we're at a Ruby conference, so like we thought maybe we'll actually introduce Elm using some Ruby ideologies. So like we can define numbers just like numbers. In Elm, we can actually define the same thing, but the difference is that we actually get a type back, which is 42 is a number, which is fine. Then we can do decimal places as well, and we actually do the same thing in Elm, and we actually get a float back. Strings in Ruby, like double quotes, and you actually have a string. In Elm, you do exactly the same thing, but with a type. There is no concept of characters as such in Ruby, so everything gets converted into a string. So single quotes H actually gets converted into a string. Whereas in Elm, we actually have a special type, which is actually called character. So similar example, hello, single quotes, but it's still hello, strings. But in Elm, it's actually a syntax problem. So like some differences. Lists are arrays. So in Ruby, like this is an array. We actually denote by square brackets. So you have like 1, 2, 3. In Elm, you can actually do the same thing. Same thing, like it actually returns a type back saying it's a list of numbers. We can just do like normal operations, how we do in Ruby, just by doing like a map. So in this case, we are just adding 1 to each of the members of this particular list. So we get 2, 3, 4 back. In Elm, we can actually do the same thing. So we actually do a list map, and then we pass in. So this is a syntax to actually do anonymous functions in Elm. So n is basically just parameter, and it's just adding 1. So we get like a new list back with 2, 3, 4. In Ruby, we can actually do this. This is like a heterogeneous list. So basically, we can actually have a list of different types. So we have like 1, which is a number, and we have ABC, which is a string, and then 3, which is a number again. If you try to do that in Elm, you get a type mismatch. Now, you think, why would they do that? They have a very sane reason for it, and that's just here. So what happens in runtime when you actually try to add 1 to that list? So you get like a type error. So you cannot add 1 to ABC, right? Like you don't know how to actually add 1 to ABC. But in Elm, you cannot actually do that. So this is like one of the ways Elm actually tries to avoid runtime errors, and it's like basically a design choice they have actually been considering. So like, yeah, this like, like by default, they stop you from doing something stupid, so you don't crash. Records. So this closest thing to Elm records we could find was OpenStruct. So basically, you define an OpenStruct point with X and Y value, and you actually get an OpenStruct back. In Elm, you can actually do the same thing with curly braces, and you get X and Y, but you actually get a type back as well with X and Y. To access any value out of that, you just use the dot operator. So you actually do point.x, and you actually get the value back. In Elm, you do exactly the same thing. To override something or to change value in Ruby, you basically just do point.x and then use the equal to operator to actually assign something back to that particular key. In Elm, the syntax is slightly different, and the result which you actually get back is slightly different as well. So everything in Elm is immutable, so you cannot actually change. So you will always get a new copy back with the updated value. So you can always guarantee that the point actually hasn't changed, and you actually get a new point back with x equals to 1. In Ruby, you can actually do point.z, which is like adding an extra key value. But in Elm, you cannot do that because all the records are actually of fixed length at the time of creation. Functions, it's pretty similar. So in Ruby, we actually use just the def syntax to actually say def, name of the function, then parameter list, and then the body of the function. In Elm, it's much easier. You just start with the name of the function, and then you pass in the parameter list, what you need, and then the body of the function. And the function also returns a type back. So in this case, it's actually saying number to a number to a number. It's a bit confusing, but we will look into that in the next couple of slides. To call a function, we just go add 1 and 2, and it will return the value back. Similarly, in Elm, you can actually do add 1 and 2, except for the commas. It doesn't actually require commas, so you actually get 3, which is a number back. So far, we have been just seeing that Elm actually returns all the types for us. So Elm is a statically typed language, and you would think that, like, so far we haven't actually written any types. And this is because Elm actually does a very wonderful job of actually figuring out types for you. So the Elm compiler actually looks at things, and then it actually tries to figure out like what kind of operations you're doing, so it can actually assign type. So for example, greet name, that doesn't say anything about that particular function. It just says that it takes one argument. But if you look at hello and then plus plus, so that's like the concatenation thing in Elm. So it actually understands that, okay, so if you're trying to concatenate a string, then name must be a string. So the result would be a string as well. So that is Elm's way of figuring out, and it will actually give you those things by default. But you can be very explicit, and you can actually define your types on the top of the definition. So you can actually write this thing that greet actually takes a string and returns a string. If you don't do that, Elm will actually figure that automatically. Similarly, square takes a number and it returns a number back, and add takes something, like it doesn't make any sense. So a number to a number to a number. So it's like it doesn't show actually two parameters. This is something in Elm which we're going to show on the next slide. So to understand that syntax, that why add says number to a number to a number, Elm implements currying by default. Like currying is nothing special. It's just a technique of functions which actually take multiple parameters and converting that into a function which only takes one parameter, right? So to understand that, like we'll actually look at this example. So if you pass like both the parameters to add, it will give you the result back 3. But say, what happens if you actually just pass in like one parameter? So you don't pass in the y, it returns you a function which actually takes another number and returns a number. So what's happening is that it's actually taking 1 and it's placing it in terms of x, and it's left a position open for y, which is the number, and the result is actually the number. So if you actually look at this in terms of execution, this is how it's working internally. So add 1 returns you a function which actually takes another parameter, which is 2, and it gives you a number back. So the syntax actually makes sense if you look at it. So it's like number to a number to a number. So the last number is basically the return, and the first sequence of things are like basically just parameters. Type aliases. So Elm, as it's statically typed, you actually write these type signatures quite a lot. It becomes quite hectic. So if you actually look at this, this is a function name which actually takes a person record, which is first name and last name, and it tries to take the person first name and last name and add it together to return a full name of a person. And it's fine, you can actually read it, but imagine that you have like this person thing which is actually littered all over your program, right? You're using this person again and again and again. So how can you actually make it easier? So what you can actually do is you can actually just define or assign it to an alias. So now person is basically an alias. So wherever we actually use person, we can actually just replace that first name and last name, and Elm will automatically do that for us. So to actually look at this example again, now we can actually just say that name actually takes a person, and it returns a string, which is the full name of the person. It is also very helpful in returning error messages back. So if you actually see, and if you pass in a different record, it can actually tell you that this is not a person record, and it's actually mismatched, and it will be very helpful. Union types. So this is my favorite feature of Elm. So if you get anything out of like the syntax part of this talk, I will say understand union types, because they have just changed how I actually think about programs, and it's very useful. So basically, languages find it very, very hard to actually deal with complex or weird shaped data, right? Like if you have, like they give you like a basic kind of a set of some types, and then you construct all of your constructs based on those types. So you use combination of strings, nulls, other values to actually create something. But in Elm, you can actually define these weird shapes using union types. So for this, we are actually going to go through an example. And the example is going to be, so basically, we have a chat application, and we have two kinds of users, a user who's actually logged in, or a user who's anonymous. Now we need to define this thing in Elm, and how do you actually define it? So we say we have a type user, and it could be anonymous, or it could be a name string. So the pipe sign is basically just an or. So a user can actually take either anonymous or a name string value. What this gives you back is two constructor functions. One is anonymous, so you can actually use that to create a user, or you can use a named, and it's basically a function because it has to take a string, so it actually returns you a function. So you can actually use named Marvin, and it will actually give you a user back. So user can only have like two possibilities. Think of it as a box, right? And those boxes can only hold two kind of values, and these are those particular values. So how do we actually use it? So say we have a function called user photo, and user photo is basically we want to show the profile photo of that user. Now, if the user is anonymous, we don't actually have their photo, so we'll show anonymous.png. If the user actually has logged in, we might actually have their photo, and we want to show that. So how can we actually deal with that, or how can we actually use union types to make our lives easier? So let's say we have a function called userPhoto, which takes a user. We can use a case statement to actually get the values out of that box, which is our user box, which has those two values. So we don't know what those values are, so we need to cater for both. So if we actually say that the user might be anonymous, and this is actually pattern matching on that particular user. So it's saying, okay, if it's anonymous, we will actually return anonymous.png. If we just stop here and we say this is done and our program's done, and you say compile, Elm will actually give you errors. And the reason it's saying that is that the box can actually have two values. It could be anonymous, and it could actually also have the named user. Now you are not dealing with the named user thing. So the case is basically exhaustive, right? It has to match for both things. So at runtime, you don't actually just experience like a surprise, hey, I didn't actually handle that case. So we say, okay, we actually have to add that case. So as you can see, we're handling the name case, but we also have this lowercase name. And that is basically matching the string. So when we say name Marvin, so Marvin will actually get associated with that name. And that's because of the pattern matching. And then we can actually use that name to return a URL format where we can actually have the user's profile image. Union types don't just stop there. Union types are very, very powerful, right? As Louis was mentioning, that you actually had the concept of maybe. Maybe is nothing special. Maybe it's just another union type. It's already defined in the library for you. So maybe of A is basically, it could be nothing or it could be just of A. So what does that actually mean? So ignoring the syntax, the first thing you can actually see is that it's nothing or it's just of A. So it is either this value or that value. So how do you actually use it? So you actually say that you have a middle name, which is maybe string. And maybe string is basically just saying that maybe this user actually have a middle name and maybe not. So it's I don't have a middle name, so I don't want the system to actually conform saying that you have to enter something for the middle name. Most of the programming languages you actually deal with, you actually have to worry about whether it's actually going to be nil or not. And when you actually return the value back, you have to make sure that you check that against it as well. Let's see how we can actually use that in Elm. So we can actually say that first name is Douglas, middle name is nothing. So you're actually explicitly saying that middle name is actually nothing, and the last name is Adams. Say tomorrow we actually figure out that Douglas actually has a middle name, which is null. So we can actually say first name Douglas and middle name just null. Now imagine that you're reading this record just like the userPhoto function, and we actually had to take the middle name out, or we have to read the middle name. If you use the case statement to read the middle name, it will be exhaustive. So you actually have to say that I have to handle a case for nothing, and I have to handle a case for just null. So it's not going to cause you a null exception or anything like that, because you actually are explicitly handling both the cases. Another example of union type is to actually handle errors. So most of the languages you have exceptions, right? How many times you have used a library in Ruby, like a gem, and you're fine and everything is working fine, and suddenly you actually have an exception and you don't even know where that exception is coming from, because that library actually raised an exception and you have to handle it, but you haven't handled it, and the program crashed and you lost dollars, or you lost sleep. But in Elm, you actually do it in a very nice way. And the way Elm actually handles it is they treat errors as data, right? Everything in Elm's program is actually data. So what they do is that say, okay, let's create another construct, and it's called result. And result can actually have two values. One could be an error, or the other could be okay. So it could be used in something like this. So say we have a function string to int, and basically it takes a string, say in string format 1, and it will try to convert that into an integer. But it also has a side effect, right? I mean, sorry, no, Elm doesn't, functions don't have a side effect, sorry. But say you're taking, if you enter b instead of 1, that is not a number, and it doesn't know what to do. So it has to raise an error somehow. Rather than raising an exception, it will just say, I'm going to raise the error value. And if I actually have something, I'll return the OK value. So let's just see how we can actually use it. So in this case, string to int is 1, 2, 3, and it can actually convert the number OK. But the idea behind this is that you just cannot use this function to get a value back. You will actually have to case match it and actually say, OK, if it's OK, I'll get the value back, and it's 1, 2, 3. If it's not OK, then I actually have to handle the error case as well. So you're just explicitly saying that this might actually crash, and you have to handle it. rather than actually, if it crashes, So, yeah. I'll hand over to Louis to actually talk more about the app.
Sure. So in order to kind of demonstrate how all of the pieces of the Elm syntax that we just showed you fit together, and also how you can use them inside of a Rails application, we put up a little bit of a sort of a demo app, which is just a fairly simple shopping cart implementation. It uses Rails as a backend with an API, and the sort of actual shopping cart page where you can change the quantities of items is done in Elm. So that's all on GitHub. We won't have time to go over all of the code today, so I do encourage you to go and have a look after the talk, if you're interested in finding out more. So this is what that looks like. It's really simple. Don't hate my CSS. So all it is this. You can add or decrease the quantity of each item. When you do that, it sends off a request to the Rails API, and then you get back a representation of the cart, and that updates in the view. We've also done a little bit of a kind of a modal checkout form just to show some things about modals. I've also done some integration here with Stripe's JavaScript library. So Stripe is a payment gateway, and they provide a way of making credit card tokens in JavaScript. And so I've done that integration just to show how Elm interacts with third-party JavaScript. That part I will not cover in the talk today, so if you want to find out more about that, you can go look on GitHub. So the first question is Elm and Rails. And so there's kind of two approaches here. One of them is, of course, Elm just compiles into JavaScript, so you can just make JavaScript and put it in your public directory and you're fine. The other option is magic. So you can just use a gem which integrates Elm into the asset pipeline. And I want to refer back a little bit to the talk earlier today, talking about Webpack, and I generally agree. I do like not having Ruby wrappers around my front-end build pipeline. I think it's nice. But if you're getting started with Elm, I kind of feel like it's good to be able to focus on the language and the architecture of the application and not spend a lot of time like figuring out how everything is glued together. So to get started, I'd say go have a look at the gem. We looked into it before the talk, and there was some open pull requests. And it wasn't quite working with Rails 5, so I emailed Frank, who's the author, and long story short, I'm now maintaining this. So it is now working with Rails 4 and 5. If you have pull requests, shoot them. I'll help you out. Cool. So how does it work? You have a shopping cart. So in this case, you put it in app assets Elm, so it just lives alongside your other stuff. You can break it down into modules however you like. So here I've got some sub modules for different parts of the app. In your something like application.js, you can just do a require here, and I'm requiring an Elm module the same as I would require any other JavaScript in the standard sprockets format. And that big blob of JavaScript there is just there to sort of patch the AJAX request to put Rails cross-site request forgery token in it, so you don't have to disable CSRF. So that just means that I don't have to worry about that in Elm land because it's all handled at the JavaScript layer. So up to you how you want to handle that, but this is what I've done. So how do you build an application in Elm? So coming back to this idea about programmer happiness and accessibility, Elm actually provides you with two ways to build applications, and one of them is, curiously enough, called beginner program. So it gives you a way of, it really has the learning curve built into the language fundamentally. And so beginner program is just a way of writing an app that has a few features missing, but for some apps it might be all you need, but as a way of getting started, it's definitely a great way to start. So beginner program basically is a whole application, but it has no side effects. So you can't talk to HTTP, and you can't talk to external JavaScript. But other than that, if your app is like entirely contained in the browser, so like maybe a to-do list or a game, you can use beginner program and never have to change to the other one. So what does beginner program look like? Elm applications are basically made up of kind of 4 components, and that's basically all you need. So the model is the first thing you're going to define. You're going to find a type of a model, and don't think of a model like a Rails model, where it's like modeling one kind of object in your system. The model in an Elm application is the whole state of the front end of this particular page or component. I should note that if anyone's familiar with Redux, Redux is heavily inspired by the Elm architecture, so if you've done Redux, this is all mostly the same thing, and it'll make sense to you. If you haven't, I'll try and explain it. So the model is everything. So it can be in the shopping cart, it can be the list of all the items and the total, but it's also things like, that checkout form modal currently displayed? So you could have a Boolean field that's like, is that shown on the page or not? Because it's part of the state of the application. And everything in your front end has to be derived from that model. I have a view function, so I define a function that takes the model and returns some HTML, but it doesn't actually render out HTML, it just returns a data structure that represents HTML, and I hand that off to the Elm runtime, virtual DOM magic patches the DOM and displays it on the screen. But the consequence of that is that my view function is a pure function. It just takes the model and returns a data structure representing HTML. It doesn't depend on the DOM, it doesn't have any side effects, so it's very, very easy to test in isolation. My view has the ability to emit messages. So I define a type of message, which is usually a union type with a few different branches. And that's like user clicked on button. Then I define an update function. The update function is, again, pure function, takes the old model and a message and returns a new model. So every time a message comes from the view, Elm takes that message, passes it to my update function with the current model. My update function returns a new model, and Elm passes that into the view, handles the update. So I've got a completely closed loop, nothing goes in, nothing goes out. So what is the simplest possible example of this? Before diving into the shopping cart example, I just want to use the canonical Elm example, which is a simple counter, which just has one number, plus or minus. So your model is usually some kind of big, complicated record type that has a lot of different fields, but a model in Elm can be anything. It can be just an integer. So in this case, my whole model is an integer. I then define a type of message, which is either, in this case, increment or decrement. I define an update function, which takes a message and a model, returns a new model. I'm not showing the implementation here, but as you can imagine, it's trivial. You define a view, which takes model and returns HTML. That might be a little bit more complicated, but we're talking about maybe 3 elements, a plus button, a minus button, and something to show the number. The one thing that you can see here is weird, is I'm not returning just HTML, it's HTML of type message. So I'm wrapping the message type in my HTML. And the reason for that is because, as I showed before, the HTML needs to know how to emit my message type. So the view needs to know about my message type in order to be able to emit those messages. And then finally, wire it all up with beginner program, set an initial value for the model, in this case 0, pass in my update function, pass in my view function, and that's the whole app. So now you have a whole application in Elm. The implementation of those 2 functions is missing, but they're not more than a couple of lines each. If you go on the tutorials on the website, you'll see that the implementation of counter in Elm is really, really very small. So that's it, it's a whole closed loop. How does that work with our shopping cart? Well, we might have a type alias for our item with a couple of fields on it. I'm aliasing product ID to integer just to make some things a little bit more readable. My model is just a dictionary of product IDs mapped to items. And then I initialize it with some hard-coded data, because in the beginner program, I don't have access to the server to get that data, so I'm just hard-coding it. My update function, I've made things a little bit more complicated, right? So increment and decrement, rather than just being simple messages, now they take a value, which is the product ID, and then change the model. So that update product count really is just a function that I've defined. It returns a new model, and it's just looping through that big list, finding the one with a matching ID, creating a new one with a higher count, merging that back into the rest of the list, and returning it. The view. This is a fun thing. I think it's a really fun part of working in Elm. My item view here takes, so I'm starting from the bottom. I'm starting the view for a single item. Takes a pair of product ID and item and returns some structure of HTML. So these div and button functions are part of the Elm HTML package, and they all work sort of the same way. They take 2 parameters. The first parameter is a list of attributes, and the second parameter is a list of children. So you can nest things very naturally the same way you would do in HTML. So very simple here. I've got the name of the item, the quantity, and buttons to increment or decrement. And you can see the onClick is just referencing my message types there. And then when I want to bind that all up into a list view, I can actually just it's a simple div, no attributes, and the list of children is just the result of mapping my item view function over my list of items. So this is one of the things that I find is really fun about Elm, is that when you're working with views, you're not necessarily working with templates or partials. Everything is a function, And if you want to compose different parts of your view using the same techniques you'd use anywhere else, which is just function composition, it works the same way. You can use map, you can use whatever you want. So that's the beginner program version. Obviously, it doesn't do anything very interesting because it doesn't talk to the server, but for some kinds of things, it can suit your purposes perfectly. Now, say I want to change to Html.program. One of the things I want to say is that even if you know you're going to need HTTP, like for this shopping cart, we knew we were going to need HTTP, but we still started with beginner program just to get sort of a working proof of concept in the browser that you could click on and play with. Because you have this really powerful type system, when you change to beginner program, from beginner program to program, you just change that one line in your code, and then it'll tell you, oh, you're missing these two parameters, and you fill those in, and say, oh, this thing doesn't have the right type anymore. Change that. This thing doesn't have the right type anymore. And it's very, very easy it's basically like a guided path from the compiler to get you from the one to the other. So I think it's perfectly fine to start with beginner program, even if you know you're going to need the more advanced features. So what does that look like? It looks almost exactly the same. So you still have that same closed loop. Everything works the same. There's just a way in from the outside world, and there's a way out. So the way in is called subscriptions. So you can define subscriptions, and then you can pass values in from JavaScript to your Elm application, and those just get passed into your update function, the same as any other type of message. So I can say I've got a subscription to some JavaScript that when the user selects a thing from this date picker, let's say I'm using a JavaScript date picker, that value gets passed into Elm, and then it goes into my loop the same way anything else would. And it gets typed, the type coercion happens on the way in, so you still have the type safety inside of Elm. And then the other thing is my update function, in addition to returning a new model, can return some commands, which is like, hey, Elm, go and do some stuff after you've rendered the new model. And that stuff is always asynchronous, so I can't just sit there waiting for the result of the HTTP call, because that would be an impure function. Instead, all of those side effects are handled by the runtime, and they'll get passed back into my update function as messages. So I define the message of got response, and then I have to handle that in my update function. So what does that look like for our shopping cart? I'm going to go over this fairly quickly. The actual update statement in the real shopping cart application has a few more branches than what I'm going to show. So I'm just going to show enough so that you get a picture of how the architecture works. So again here, my command, it's not just a command, right? It's a command message because it needs to know about the message type so that it can return it back when it's done. So in the case of just showing or hiding that checkout form, what's happening here? I'm changing a field on the model. So I'm changing the status, and that will flow into my view and allow me to say I'm displaying the modal or I'm not. And then at the end, I've got the special value command.none, which says we're done here. We don't have any side effects from this. This is just all we're doing is changing the way the view renders. If I actually want to do an increment or a decrement, so my model is actually unchanged here, but I'm generating a command. And so this update item, it's a function that I've defined, and it's using Elm's HTTP library, basically, to build up a command that knows what URL to go to and what message type to return. I'm not showing the details here because the HTTP library details are a little bit out of scope for the talk, but you can imagine that it's just returning a command. And then finally, if I get the response using that same result union type pattern that Rahul showed you before, we can match on either OK, and I get a new cart, in which case I change the cart in the model, and that'll flow through to the view. Or I get an error. I figure out how to format it using some code that I wrote, and then add that on the model, and the view knows how to render that. So that's sort of an overview of how we've wired this stuff all together. And I encourage you again, because we haven't had time to go over the whole details of how this thing hangs together, to go and have a look at the code. If you have any questions, come see us. I'm happy to also sit and walk you through it if you want. And you can also just pop an issue on GitHub, and I'll answer any questions there. So yeah, so Elm for me has been a lot of fun. It's been really enjoyable to be able to write front-end code and just feel like I'm as productive and having as much fun as I do when I'm writing Rails or Ruby code. And I've never had that before because JavaScript has always been like, I don't know what I'm doing. Finally, I think we're nearly out of time. So I'll leave you with one tip, which is that if this all seems interesting to you and you want to go out and start writing some Elm, I would encourage you, before you just start hacking code, just go and work through the architecture tutorial on the website, because it will avoid you having any misconceptions, because it's a frame of reference shift coming from Ruby where you expect if I write a method that says http.send, I get the result right away and I can do something with it. And it's enough of a frame of reference shift that I think you'd trip yourself up if you didn't do this. So this is a it's a short, really good tutorial that explains all the concepts and totally worth doing. It'll avoid a lot of problems. So that's it. That's all the time we had. Again, this is us on Twitter. We work at REA. We're hiring. Yay.
You can come and find us near the REA booth. So.
Cool.